Okay, so we are going to be talking about how we use file systems. So Module 3, Unit 5, using file systems. So our objectives for this lecture are to talk about what is a file system. Okay, when we are putting away our laundry, do we just take it all and put it in a basket and then have to dig through it all the time? At my house sometimes, but we really shouldn't, right? We should fold it up and put our shirts with our shirts and, our pants with our pants, and it makes it a lot easier to find things. Well, the same is true with the computer world. So today we're going to talk about kind of those organizational structures that allow us to manage files from within the operating system. We're also going to talk a little bit about search tools that allow us to find those things even quicker. Okay, so if I'm like, I need this shirt and these pants, boom, I can find them. The same is true in our operating system. So when it comes to managing file systems, we have physical disks, okay, and we talked about this previously, and our hard drives are what store all of our information. And if the power goes out, guess what? That data is still there. So if you remember from the last lecture, is that volatile or non-volatile? Correct, that is non-volatile storage. Okay, our hard drive is our non-volatile storage. So when we boot up our computer, we have an operating system, we have pictures, music, movies, files, all those things. Those all reside on our hard drives. Okay, so that's the physical disk. Now, on top of that physical disk, we have what are called partitions. Okay, so with partitions, we're able to take our hard drive and we're able to, let's say this is our hard drive here, we're able to section off our hard drive and say, okay, this is for our operating system. This is for our files, okay? And what's nice about this is, for example, I'm at a conference right now, and I brought my Dell that I got like 3 years ago, and it's time to kind of do a fresh, clean install. So when I did that, I was able to just clear out my operating system. All of my files stayed here, so my virtual machines, my photos, some videos, all of those could stay there. So this is my hard drive here, but I can separate it into different sections, okay? So with that, we take our hard drive and we divide it into separate storage areas, okay? And what's cool about that is each partition can actually have a different file system, okay? So on the Mac side, we use a different language, let's say, than we do on the Windows side. The same is true with Linux. So if we have that hard drive that we saw earlier, let's go ahead and see if we can go through and clear all this out. We have that hard drive that we had earlier. We can actually go through and say, okay, this is now our Linux partition. This is now our Windows partition. Okay, so when your computer boots up, this is our computer, it's booting up, we can actually choose, do we want to boot into Windows or do we want to boot into Linux? Okay, so that way if you don't want to virtualize, you want that full immersive experience, you can do that. Okay, so that's pretty cool that hard drives have that availability or that ability to do that. You must have at least one partition on your hard drive, okay? So in order to put stuff in a drawer, you have to define that that is a place to put it. And that's what our partitions do. They say, hey, computer, you can go ahead and store stuff here, okay? So with Windows, you can see here, we have our different types of drives, okay? So you see where that number 1 is right there. That is usually our C drive on Windows. That is kind of our main operating system drive, okay? Our C drive is the standard for all of our operating system files, all of our Windows files, stuff like that. They all live on the C drive, okay? And then everything else beyond that are assigned different drive letters, okay? So back in the day, our A drive equaled our floppy drive. Our C drive equals our operating system, and our D drive equals our first optical drive. Okay, so what do I mean by that? So you can see here that we have this Blu-ray disc drive in this screenshot. That is our first optical drive. Okay, so like CDs, DVDs, all that kind of things. that allows us to access Blu-ray discs, DVDs, and stuff like that. And then everything beyond that is added on. So we can see number 3 there, that's an expansion drive, okay? So that's like, maybe we use that for our data backups. And then below that, number 4 is a flash drive, okay? So that might be something that we have on our keys as like our temporary storage, okay? So those are our different drives as they would show up in the Windows operating system. So when we get our hard drive, let's say we run to Best Buy, we get a brand new hard drive, it's time for us to put a partition on it, okay? So when we partition it out, we can say, okay, I want to say 40 gigabytes for our operating system. Now we have to tell it what language we want it to speak. Remember a couple of slides ago how I talked about, how partitions can have different file systems and stuff on them. The most common ones for Windows are FAT, or the File Allocation Table, and NTFS, or the New Technology File System, okay? So the big difference here is FAT is usually used for smaller drives, okay, your flash drives and stuff like that, and NTFS is used for your larger drives, okay? And with NTFS, we added a few other things. We added things like encryption and just the ability to move very large files, stuff like that was all added on NTFS, and that's why Windows has to use at NTFS, okay? So FAT is our file allocation table. This is going to be for smaller drives like flash drives. NTFS on the Windows side is what we're going to use for larger file systems. So if I were to take an NTFS drive, or a Windows external hard drive, let's say, and plug it into a Mac, it's not going to read it without special software because that is the language that it's speaking, okay? So Windows equals NTFS. When it comes to our optical drives, these are like CDs and DVDs, stuff like that. They use the Universal Disk Format, or UDF, and the CDFS, or the CD file system. I don't think you really have to necessarily know that as much for the certification. It is just for your own knowledge. And then on Linux and Mac, on Linux side, we use ext and ext3 and ext4. Those are the file systems that Linux uses. And HFS and the APFS, or the Apple file system, are what are used on Mac, okay? So I would go through and make a flashcard for 3 things on this slide, actually 4 things on this slide. FAT equals, and that's going to be your flash drives and stuff like that. NTFS equals Windows. EXT 3 and 4 equal Linux. And then HFS and APFS, just put that on one flashcard, and then put Apple, okay? So what exactly can a file system allow us to do? Okay, why do we need to have a file system? Well, first and foremost, it allows us to do compression. Okay, so compression takes large files and it makes them smaller, so it uses less room on our disks. It allows us to have encryption. Okay, so that way if someone gets a hold of our laptop, they can't access the files that are on there. Permissions, okay, especially once you get into the server world. Permissions say, hey, who can use this file? Okay, can the accounting group use it, or the marketing group? Okay. Journaling, keeping track of changes. You see this on the more on the Mac and Linux side, but journaling allows us to see, what changes happen. And I'm not saying that that doesn't work on Windows, but you see it a lot more on the Linux and Mac side. Kind of some of the limitations, okay? Are there certain characters that we can't use? And then how we name things, okay? So on NTFS, HFS, and ext4, it is case aware, which means if we create a photo called llama with a capital L, it's going to be different than the llama with a lowercase l. Those are 2 different files, okay? So again, you could see this little chart here that helps you understand, and you could see that on the FAT32 side doesn't have a ton of features, where these more modern file systems that you see over here, those ones do have, they're a little bit more rich as far as our feature set is concerned, Okay. So when it comes to folders, these are like the drawers that we have in our dresser, okay? Or files or folders in a filing cabinet, okay? So on the drive, we have all these different folders, and then inside goes files. And what's cool about this is we can go through and say who has access to what. Okay, that's where our permissions come in. And this is also where, when we have our different partitions, where we can have our operating system be different than our actual files, the folders are what allow us to also do that, okay? So you can see here, we have our root folder, which is our C drive, and then from there we have a new folder. It is called Windows, and then inside Windows is a new folder called System32. So it allows us to organize our files, okay? So back to our dresser drawer, okay? We'll put a mirror on there. We'll see your smiling face because you're so excited to get the certification. We have a folder called Shirts. We have a folder called Pants. We have a folder called Socks. We have a big one called Hoodies. We love our hoodies, okay? So this allows us to organize all of our stuff. Inside of our hoodies folder, maybe we want to have one that is for our blue hoodies. Maybe we want another one for our red hoodies, okay? And these exist inside the actual hoodies folder, okay? So, again, folders allow us to keep all of our stuff in a nice, organized fashion. Windows system folders. So the system root, like we kind of showed on that last slide, is the C Windows folder and then the System32 folder. This is where all the important Windows stuff lives. Please stay out of there, okay? We our users, ourselves, we don't really have to go in there for anything, okay? Unless you're following a tutorial that specifically says, hey, go into the System32 folder, pretty much we want to stay out of there, okay? All of our applications, they need a little bit of space to save stuff too. So that's where our program files come in. Okay, so program files, or the programs directory, or on the Mac, the applications directory. That's where those applications are going to live. Okay, and then our users have storage as well. Okay, so you guys might have pictures, music, movies, stuff like that. So what does this look like in practice? Well, we have our root, so in this case it's our C drive, okay? So from there we have our Windows, okay? And then we also need space for our applications, okay? So on the Windows side, this will be our programs, or our program files, okay? And then our users are also going to need some room. So we have a users folder, and then from there we have a directory of our different users. Okay. So again, this is mostly on what I'm talking about, how this is laid out. This is on the Windows side. Okay. Linux and Mac are in fact a little bit different in that in those you basically have just a root. So instead of having this C:/, we just have root, and under root we would then have our home directories, and then we would have other things, but everything kind of lives at that root and then builds out from there. So if you see this little symbol, that is our root directory, or that's where everything starts. Okay, so hopefully that makes sense, and we'll get more in depth with that as we progress through the different modules. So for this slide, Windows saves everything in the Systems32 or in the Windows folder. Program files, that's going to be where all of our applications like Word, Excel, PowerPoint, Chrome, all of those things, that's where they live. And then we have our users, which is where all your stuff lives. So all your pictures, music, movies, stuff like that. So when it comes to Linux, we have what are called directories, okay? So I talked about this a little bit before. So everything starts in Linux at this part right here, the /, and that is the root folder, okay? So from there, we all start there. There's not really different drives, okay? So let's go ahead and draw a little demarcation line here, okay? And this is our Windows side. And this over here is our Linux side. So let's get rid of that real quick. Okay, so this is our Linux side, okay? So on Linux, let's say we have two different drives, okay? And this is going to be kind of a confusing thing to understand until you use Linux for a minute, okay? So right now I just need you to kind of bear with me. So in Linux, we have our root, okay? Under root, we then have our home directory and our different directories that are under there, okay? And then we have this other thing called mount, and in mount is where our hard drives actually live, okay? So this could be hard drive 1 and hard drive 2, okay? But even though they are like in this directory, if you will, you actually access everything like you would in the normal hierarchical Linux file system, okay? Now on the Windows side, we have our C drive, we have our D drive, okay? We have all of these things, and then we build out from there with our Windows, our users, etc. Now, if we wanted to, we could actually have if we had two hard drives in here, unlike Linux, we could have our D drive be where our users live, okay? But we would have to go all the way back because root is back here, okay? So you go to root, and then you go to the C drive, or root, and then to the D drive, the E drive, the F drive, whatever it might be. Whereas on the Linux side, everything starts at root, and then you go right into your directories. So even if we have our home directories, which is our users, we can have them be on, HD2. They would just be, you would do that through mounting it and directing them to say this is where that lives. Okay, so again, on the Linux side, everything starts at root. You don't really have drives per se. Different storage drives are just used within the file system itself. And if you have questions on that, feel free to put them in the comments or shoot me an email at tj@tjhouston.com. Okay. Okay, on the Linux side, on the Windows side, when it comes to actually getting to these files, we have what's called File Explorer. Okay, so with File Explorer, you can see here, we have our different drives on the left-hand side. We double click on it and we can access everything. Now you also have this thing called quick access. So if there's stuff that you use all the time, you can have those in your quick access section. So you can see documents and downloads are pinned to that quick access. Otherwise, if we wanted to go to the users downloads file, we would have to go to click on C, and then we would have to go to our users directory, and then we would have to go to James, and then we would have to click on desktop, okay? So what quick access allows us to do is just pin stuff right here. Stuff that we use all the time can just be pinned right there, okay? So the Windows Explorer or just Explorer allows us to do that on the Windows side. So when it comes to saving different settings and stuff like that, that's actually saved within our profiles, okay? So all of our pictures and stuff like that, those are saved within our users folder or our home directory, and it has different, you have the ability on Windows to use different libraries. So these are kind of like database-driven ways to keep track of like your photos and stuff like that. And then you can share those out as you see fit. So you can see here, optimize this library for, just documents, and then you can say, you might have a documents library that has documents for, your kids' Little League or, stuff for work, stuff for play, all that, and they can just live in that library itself. Personally, all my stuff lives on the cloud, so I just organize it by folders up in the cloud. But if you are, if you don't and you use your local machine, libraries could be helpful for you, okay? So when it comes to creating our actual folders, we have to keep a couple things in mind. Number one, they have to be unique at the same level. So what does that mean? So what that means is we have our C drive here. So you can't have two exact things called users, okay? That would be very confusing. You wouldn't know where to put stuff. Just like if you had a dresser that only had drawers that said socks on it, okay? It just doesn't make sense unless you have a specific partition or a separate, dresser just for all of your socks, okay? So they have to be unique, okay? So this could be users 1 and this could be users 2, let's say. That's totally fine because they are, in fact, different, and the operating system sees them as being different. You're not allowed to have certain characters, so again, we can't use these slash characters in our folder name because we're actually using those to denote the actual paths that we're going to, either forward or back, okay? The full path cannot exceed 260 characters. So what do we mean? So starting at RC all the way to the end, it cannot exceed 260. So that means we can't create a folder called 1 and inside put a folder called 2, inside folder called 3, and so on and so forth to 261, okay? It's going to break. It has to be at 260, okay, as far as the characters that we have, okay? It's also worth noting that there's a difference between case-aware and case-sensitive. Case-sensitive, on the Linux side, Linux is case-sensitive. So I can create two files called, like I said, llama.txt with a capital L and one with a lowercase l. Those are two totally different documents. Whereas on the Windows side, it might look at them as being the same. So it's not going to be as strong as far as enforcing some of those rules, okay? So what are files? Well, files are, think of like text files or binary values, that basically chunks of data that are stored within our folders. So at the end of the day, remember, computers can only understand binary. They only know ones and zeros. So that's all these files are different, basically they're different references or different presentations of that binary data, okay? And then at the end of the file, we have our actual file extension, okay? This file extension is what allows us to denote how that presentation will be interpreted. So what do I mean by that? So if I have a llama.txt, it's going to open up in my text editor, okay? Makes sense. If I have a llama.jpg, it's going to open up in my photo editor, okay? Because this section here is delineating what our actual files or our file extension is, okay? So everything after the period is our extension, okay? So this is going to tell us what type of file that it is, okay? When it comes to creating files, we can right-click on our desktop, create new. From the application that we are in, we can go to like File, New. We could do it from the command line, so we can do we could do create, or on the Linux side, we can do like touch that just keeps creates a blank file, and then if we want to open a file, we can either double-click on it or right-click and then click on Open In, okay? When it comes to our actual File Explorer, it is an application. So that means it has different preferences that you can customize based on what your needs are or what your users' needs are, okay? One of the things that we use all the time is showing those file extensions, right? Because as super tech people, we need to know what kind of file it is, because if we get a help desk ticket that says, hey, I double click on this PDF and it opens up my text document, we need to be able to look at it and be like, well, it's saved as a .text, so even if it is llama.pdf.text, well, you have that last part there that is .text, and that's what's making it open in our text editor, so we can figure that out. But that's not something that the user necessarily needs to see. So you can actually go into your settings and show like file, whether or not you want to show file extensions to the end user. Another common thing that we have to use is the hidden files. Okay, so there's actually a attribute in a file that says whether or not it is hidden. Okay, so if we go into our folder options, we can scroll down and you can see this section here for hidden files and folders and whether you show them or don't show them. For the end user, absolutely don't show them. But for you, you should probably turn that on. So that way if you're looking for a file, or you need to make changes to an application file, you can see it even though it is hidden. Okay. Renaming, copying, moving files and folders. You're able to rename any of your folders. You can right click on it and change it. And then unless you put in a new file extension, or you'll have to show file extensions and then change it there in order to change it from .text to .pdf. When you just rename the file, it's not going to change your actual extension, okay? So deleting files, we also have the ability to delete stuff. Now, it's worth noting that on the Windows side, everything is kept in the recycle bin, okay? So that's basically a fail-safe in case a user doesn't mean to delete their file. They're actually able to go in there to the recycle bin and undo that accidental deletion. And then from time to time, you can right click on that recycle bin and you can delete those files, or if you have an application like CCleaner, it can delete those files for you as well. If you do want to just permanently delete a file, let's say you accidentally created something and you don't need it to go to the recycling bin, like what you're doing, you can actually hit Shift and delete and it'll permanently delete that file. It's also worth noting that there are no recycle bins on flash drives or network shares, okay? So, as a sysadmin, we might be able to recover some stuff, but for that actual end user, that's a no-go, okay? There's not a specific place that they can go to recover those things. So when it comes to working with files, we might need to work with several files. Maybe we want to open up 3 different pictures. You can actually do Control A if it's only those 3 folders that are or 3 files that are in a folder. You can actually just do a Control A or Command A on the Mac and select all of those files. Or you can hold Control and then click individual files. Maybe there's 100 files in there and you only need to open 3. You can hit the Control button and then just click on the ones that you need. And then you can also use your arrow keys to do that as well. So let's talk a little bit about attributes, okay? I know this is a longer lecture and I do apologize, but feel free to take a break and come back to it if need be. So file attributes, okay? With file attributes, you have read only. That means people are only going to be able to, open that file. They're not going to be able to make changes to it. We have that hidden attribute that we talked about a little bit earlier, okay? With hidden attribute, you're not going to be able to see those files, okay? It's not going to show up unless you go into the settings like we looked at and show hidden files and folders. The S attribute that says, hey, this is important just for the operating system to use. And then there's this one called archive. I've never used it, but it shows whether a file has changed since the last backup, okay? So this is our file properties dialog. You can see that there's a couple different options here. Note the attribute that we were just talking about there. Where it says attributes, you can see, read only and hidden there on the bottom. And if you do want to be able to change it, you can uncheck that box. You'll probably get a little UAC prompt that shows up that says, hey, you probably shouldn't be doing this. And you'll be able to make those changes as you see fit. So from there, we have different permissions, okay? So I want to point out something. Attributes are different than permissions, Okay, so the attributes say, hey, there's just a couple things like read only and hidden and whatnot. Permissions are actually saying who gets access to what. Okay, and if someone double clicks on it and tries to access it, they are going to get an error message. Okay, so when you need to make these changes, let's say we're setting up a brand new file share for a small business. We create our partition, we put NTFS on there, we create a folder called departments, and inside there we have our 3 different departments. We would right click on that folder and then go to our security section, and then we can go to our actual permissions here. Okay, and then you can also see that there is this advanced dialog as well. And then you can give people a couple different permissions or different options when it comes to those permissions. Okay, we can give them full control. This means they can add, change, update, delete, modify. Basically, they can make changes to it, but they can't delete it. Read means just exactly that. They're going to be able to open it. And then write, so let's say we have a folder called sales, and at this sales we give people write access. That means they can place stuff in our actual sales folder. Okay. So from there, if we need to look for things, the easiest way is on the Windows side, hit that Windows key, and then start typing and looking what you're search for what you're looking for. Okay. Now, what is the technology behind this that makes it go so fast? It is called indexing, okay? Indexing is basically going through and seeing what all is on this folder or this section, and what where these files are actually located. So if you boot up a computer and put 5,000 files on there and try to use instant search, it's probably not going to work. Okay, because it's going to take time to index, and where it's basically identifying where these things are located, and then it's saving that information in our in an index database of some sort. Okay, so if you press start or hit the Windows key, you can bring that up on the Windows side. On the Mac side, you can hit Command space, and it'll bring up your search bar, and you can search for stuff that way as well. Now, actually, from within the operating system, you can search for things. You'll notice here in our File Explorer that there is this option here for search. So you can type in what you're looking for. So in this case, you can see CompTIA. So all of these things have to do with CompTIA. And then you can also go through, if you click on this little search thing here, you'll see that this is called our ribbon UI, R-I-B-B-O-N. The ribbon UI brings up a couple other options, okay? So you can save this search, so maybe you're going to be using it all the time, or maybe you just want to look for just like PDFs. Okay, you can go to this other properties section in order to tell the system that as well. So you do have some more advanced functionality if you actually open up File Explorer. Okay. So continuing on with our search ribbon here, if you look right to the left of it, you have this option for view. Okay. So with view, I can say, hey, I just want to see just JPEGs, or I just want to see, or I want everything to be in ascending order, which means it's going to count up. So if we had a file called 1, a file called 2, a file called 3, they will all be lined up. And then we can arrange it by, file type. There's a lot of different things that you can do to get the data that you need, and that is all from the View ribbon AI from within Windows Explorer. Okay, and Linux and Mac have similar features as well. So we've talked about file types and extensions quite a bit, but these are some of the most common ones that you're going to use. So when it comes to word processing or working with text, we're going to have our TXT, which is basically the, just the text. No fanciness, no bold, italic, anything like that. It is just the text. From there, if you do want some of that formatting, the very base level is RTF, okay? Now, if you want all the formatting, the page breaks, the headings, all that stuff, you're going to have to use either ODF, which is the open document format, or doc and docx, okay, and those are Microsoft Word proprietary type of file extensions. When it comes to our spreadsheets, we're going to see XLS and XLSX. So again, for Microsoft Excel files, you also might see one called .csv. This is a mix between a text document and a Excel spreadsheet, in that we have all of our values separated by a comma within this document. So it allows us to import that data a lot easier. You'll be working a lot with CSVs in your, in the IT world. So again, be aware that a CSV is just basically all of your different values separated by a comma. And what's nice about this is it's a standard that's been used forever. So if we wanted to import, let's say, names, we could have our usernames all in, basically we have a bunch of new users that are coming in. So like I have new students that are coming into the classroom this year. I can get a list of them and just boom, directly import it. And, it allows me to put them into our software that we use for the classroom very easy, because CSV is in fact a standard. From there we have PPT and PPTX. For presentations, you'll also have, it's worth noting that there's a Mac version of these as well. So there is a .pages folder for word processing, .numbers for spreadsheets in Mac, and then /keynote, which is what I'm in right now, for presentations, for presentations. And then finally we have our PDFs, which is portable document format. What's cool about PDFs is it's basically a final format. So when you're done creating in any of these, you can create a PDF, and it makes it so people can't really make changes, and that is better for print and stuff like that. Now we're going to move on to image file types. So these are for pictures. So you can see here we have our JPEG, our JPG, or our JPEG. This is a lossy compression, which means we're going to lose some of the original information and the reason that we do this, you might be like, well, I don't want a bad photo. Well, with cameras the way they are, there's so much information, we don't really need it. So, and if we did keep all that raw information, our files would be huge and we wouldn't be able to store them. So JPEG is a type of compression that you can still keep a good quality image, but you might lose some of that data. From there, we have our GIF. So this is a lossless compression, so you're not going to lose information, but it's an older... GIFs also allow you to have like movement in the photos. That's probably how you know them. There are also this is a debate that goes, but it might be a GIF or a GIF. I'm pretty sure it's GIF, but to each their own. Then we have TIFFs, which is our tagged image file format. TIFFs are used on the photo industry side, also on the scanning side. And then we have PNG or PNGs. This is a 24-bit lossless format. So this was kind of an upgrade from GIF. It's just, again, better quality. And then BMP, which are bitmaps, which are used on like apps like Paint and stuff, but that's pretty much it. You're not, to my knowledge, and there's probably some weird corner case out there, we don't really use BMPs for very much. Then we have our video file types. So MP4, MPEG, FLV, WMV, and AVI are the most common. It really depends on the application, right, and what you are trying to do. MPEG is what we use an MP4 quite a bit on the video recording side with like, consumer cameras. And then most of the time it's, dealing with MP4s is what we're using quite a bit. But these are just different ways to compress and store different video files. Same thing with audio files. You have your MP3 all the way up to like FLAC, which is a file size compression without discarding audio. So FLAC is a, for the audio files out there, it's probably to my knowledge, one of the best, where us normal people are used to listening to MP3s and stuff like that, where FLAC it was designed to be more like right off the record type of thing. Executable files, so these are things that are going to actually open up an application. So on Windows, we have MSIs, which are installers. EXEs are applications. On the Mac, we have our apps, or our .app. Those are, what's different is pretty much everything on the Mac side is compressed into this .app file, where on the Windows side we use the MSI in order to install different files throughout that operating system in order to get it to work. So it's just a little difference between how things are done on the Mac and PC side. And then we have these last things, which are our scripts. Basically, it's just a list of to-dos that are buttoned up. So when you double click on one of these, it'll go through and do your different commands that you put in there. Kind of a one at a time thing. So let's say you have a new computer and you want to install a bunch of applications. You can run a script and it'll go out and do all of that. So like I have one of those for Linux on my GitHub that it basically, every time I fire up a new instance of Linux, I just download this script and it installs all of those applications. So compression is a beautiful thing, okay? So compression allows us to button things up. Think of it like folding, right? If we are efficient with our folding, then we can fit more items into our dresser. Well, compression is the same thing, okay? So it's a way to go through and organize things. And let's say a bunch of files, we can select all of them, right-click, zip them, and now it becomes one folder that has been zipped up, and it's smaller, and it allows us to move it between computer to computer a lot easier. Now, there are a lot of different compression formats. The most common is zip, and that works across Linux and Mac and everything. From there, we have tar. This is mostly on the Unix and Linux side, where you're going to see tar files and untarring. RAR is used. It's a specific type of program that had a different algorithm on how to make things smaller. So some argue, a little bit more efficient. Basically, large files take up less space is the difference. 7-zip, huge fan of 7-zip, the actual application, because it can open all of these types of files. I don't have to have 10 different programs to open these. Whereas, zips and stuff, those are built in. Zip is built into the operating system, but, RAR and 7-zip and ISOs and VHD, all these other ones, they would require a different type of application, where the application 7-zip you can download for free. It's open source, and I install it on all of my machines because it's really good. ISOs are snapshots. GZ is, again, it's just another archive format like these other ones. Gunzip or gunzip on the Linux side. ISO is a snapshot of that was mostly used for like CDs and DVDs back in the day, but we still use ISOs for our virtual machines. And what's cool about this is we can do what's called mounting the ISO. So if we mount the ISO, so for example, on the Windows side, we have our C drive, right? And then we have our D drive. Now we can put our DVD in that actual optical drive, and then it'll start spinning up, and then we can get data for it. Or we can do what's called mounting the ISO. So what happens is it kind of creates this other drive, and then the ISO will show up here, and I don't want to say fools, but the operating system basically sees it in the same way as if you put a drive in the actual optical drive itself. So ISOs are used quite a bit on the sysadmin side, the IT side, especially when you're like learning different operating systems in VirtualBox and virtualizing them. You'll mount the ISO in order to go through that hard drive, through that installation. And then once it's done, you'll have what's called a VHD, or a virtual hard disk. Okay, so this is it emulates the actual hard drive that you would normally have on your computer, but it's in a virtual space. Okay, so when we install that new version of Ubuntu onto our machine, we mount the ISO, we go through the installation, and then it creates a virtual hard drive. Again, that'll make more sense once you actually start playing with virtual machines a little bit, but just note that is a type of compression format, okay? So again, this was a pretty long lecture, but all good stuff. We are getting to the end. We're on the back half of all of the lectures, which is pretty awesome. I'm going to try to get as many done as I can this week to get them uploaded and finished just in time for the new Tech Plus that's coming out from CompTIA. But in this section, we talked a little bit about the properties of file systems and how to use, how to choose the right file system. We talked about a file manager, how to create, open, move stuff around. And we talked about how to use search tools in order to find things quickly and efficiently. So hopefully this helped you. If you have absolutely any questions, feel free to reach out in the comments below, or you can also email me at tj@tjhouston.com. Thanks for watching and have a good day.